Hello Year 3s, how are you? Welcome to another Problem of the Week! Now, before we begin this lesson, I want to introduce you to a great friend of mine, my amazing maths assistant, Tao Tao the bear! Come on, Tao Tao!
Yeah!
Okay, Tao Tao, calm down.
Yay!
And now these are the Year 3 children, say hello!
Hello, Year 3s! You look very smart.
Well, they are. They're very smart and they're great mathematicians. Yeah. You've been doing some amazing maths work at home, haven't you? Brilliant. Now, Tao Tao is going to help me with our lesson today. He's got a big question for you to think about. Isn't that right?
That's right, so get ready!
Now, I know that you'll be able to answer the big question if you think very carefully. So, let's begin.
Yeah.
Our lesson today is all about adding fractions. Now, this might be totally new to you, but I know by the end of the lesson you'll understand adding fractions really, really well. I've got a question that I want you to think about and try to answer, even if you've never added fractions before. So have a look here. Mo says 1/5 plus 2/5 is equal to 3/5. Mark doesn't agree. Mark says 1/5 plus 2/5 is equal to 3/10. So whom do you agree with, Mo or Mark? Who do you think has the right answer and why do you think so? Now, even if you're not sure, you could have a bit of a guess which answer makes most sense to you, or you could pause the video and go and explore. I'm going to reveal the correct answer now. Mo was correct. 1/5 plus 2/5 is equal to 3/5. Now look carefully at the fractions. What do you notice? What do you notice about the numerators, the numbers on top? What do you notice about the denominators, the numbers on the bottom? Well, you've added the numerators. 1 plus 2 is equal to 3. And what's happened to the denominators? They haven't changed. So that's interesting. When you're adding fractions like these, you add the numerators, but the denominators don't change. So, are you ready for Tao Tao's big question? Here it comes. Okay, Year 3s, are you ready? Here comes the big question. Why do the denominators not change? Why don't we add them? Why do we only add the numerators? Let's have a think about that. I know you'll be able to answer the big question by the end of the lesson, so pay attention, think carefully. We're going to answer Tao Tao's big question by using something called unitizing. And this is where you're thinking really, really carefully about what you're counting, what units you're using. So the units are what you're counting. Let's look at a few examples. What can you see? 3 cupcakes. Now, 3 cupcakes is the same as 3 lots of 1 cupcake. Isn't that right? So you can think of 3 cupcakes as one group of 3 cupcakes or 3 groups of 1 cupcake. And 2 cupcakes is the same as 2 lots of 1 cupcake. So if we're adding these amounts, what could we say? We could say 3 cupcakes plus 2 cupcakes is equal to 5 cupcakes, or 5 lots of 1 cupcake. Now, what are we counting? What are the units here? We're counting cupcakes. The units are cupcakes, aren't they? Next example. 4 cats is the same as, yes, you've guessed it, 4 lots of 1 cat. And 3 cats is the same as 3 lots of 1 cat. And if we're adding these, what would we say? We'd say 4 cats plus 3 cats is equal to 7 cats, or 7 lots of 1 cat. Now, what are we counting this time? What are the units? They are cats. We are counting cats. The units are cats. Does that make sense? Another example. What are you imagining this time? Well, 5 kilograms is the same as 5 lots of 1 kilogram. Isn't that right? And 1 kilogram is the same as 1 lot of 1 kilogram. Now, what if we were adding these amounts? What would we say? 5 kilograms plus 1 kilogram is equal to 6 kilograms. You could imagine it like this, or as 6 lots of 1 kilogram. Now, what are we counting here? What units are we using? We're using kilograms, aren't we? We're counting kilograms. Now, what's all this got to do with fractions, you might be asking? Well, pay close attention to this example. Yes, do. So, 2/5 is the same as what? 2 lots of 1/5. Isn't that right? And 3/5 is the same as, what are you imagining? 3 lots of 1/5. Isn't that correct? Now, what are we counting this time? What units are we using? Think carefully. 1/5. We're counting these, aren't we? We're counting 1/5. So, what if we're adding 2/5 and 3/5? What could we say this time? We could say 2 1/5 plus 3 1/5 is equal to 5 1/5. Can you see that? Excellent. So 5 1/5. Now we normally say 5/5, but it means 5 1/5. 5 lots of 1/5. Another example. 3/7 plus 2/7. Now, what are we counting this time? What units are we using? The units are 1/7. We're counting 1/7, aren't we? We're counting these. Isn't that right? Or these. That's 1/7 of the whole bar, the whole rectangle. Isn't that right? So we're counting 1/7. So do you think you can complete this sentence yourself? How many 1/7 plus how many 1/7 is equal to how many 1/7 in total? Give that a go. Well, I'm going to reveal the answers. 3 1/7 plus 2 1/7 is equal to 5 1/7. Isn't that right? Again, we normally say 5/7, but it means 5 1/7, 5 lots of 1/7. Does that make sense? You could think of it like this. Can you see the 3 1/7? They're here. And can you see the 2 1/7 we've added on? They're here. And can you see how we've got 5 1/7 in total shaded? Isn't that right? 5 shaded out of 7 in total. 5 7s, 5 1/7. Now look at these questions. I want you to pause and work through them, thinking what's the same and what is different about them. I'm going to go through them now. Are you ready? 4 cakes plus 7 cakes is equal to 11 cakes. 4 kilometers plus 7 kilometers is equal to 11 kilometers. 4 pounds plus 7 pounds is equal to 11 pounds. 4 trillion plus 7 trillion is equal to 11 trillion. And 4 twelfths plus 7 twelfths is equal to 11 twelfths. So, what's the same? What's different? Well, what's the same? It's always 11 of something. Our answer is 11. What's different? The units change. What we're counting changes. Isn't that right? A final example before we answer the big question. So 3 cats plus 2 cats is equal to 5 bananas. Happy with that? Excellent, let's move on. Excuse me, I am not happy with that, not one bit. 3 cats plus 2 cats equals 5 bananas, but that's ridiculous. Well, you're right, Tao, it is ridiculous. The question is, why? Why is that such a ridiculous answer? Can you answer that at home? Well, what about you, Tao? Can you tell me why you think that answer is so ridiculous? Well, let me think. I mean, you're counting cats. The units are cats, so the final answer, the whole, the total will be all the cats you have. Can't be bananas or anything else. That's just bananas. Yes, absolutely right. Excellent answer, Tao. If you're counting cats, the answer will be some amount of cats, won't it? It can't be some amount of anything else. Brilliant. So, what about our big question? Do you think you can answer it at home? Why don't the denominators change when you're adding fractions? 1/5 plus 2/5 is 3/5, not 3/10. Have a think. Can you answer it in full, clear mathematical sentences using your learning from this lesson? Our answer is coming up now. Are you ready for it? Here we go. The answer to the big question. The denominator tells you what you are counting, what units you're using. Here, we're counting 1/5. So the total will be all the 1/5 we have. Yes, Tao. Excellent answer to the big question. So just like if you're counting cats, the answer will be some amount of cats. If you're counting 1/5, like we are here, the answer will be all the 1/5 that you have. That's why the denominators don't change. They're the units. The units never change. Does that make sense? Now, I do have a final question for you to think about in your own time before I show you the independent tasks that I want you to do, and it's about subtraction. So 2/5 minus 1/5. What would the answer be and why? And to answer that, I really need you to think about all our work today on unitizing. So I'm going to leave that one with you to think about. Great work so far. Now some questions for you to do in your own time at home. Here are the first 3. So thinking carefully about your understanding of adding fractions now. 2 problems, reading and thinking very, very carefully, and choose a good method each time to help you answer the questions. I'm going to show you the answers now, so pause if you're not ready for them. Here are the answers for the first 3 questions. Now for number 2, I didn't draw all the models, but the answers are there. And then the problems. Some possible answers. I hope you got on well with those. Well done, year 3s.
Well done, year 3s. Amazing work.
Yes, indeed. Amazing work. Now make sure you tune in again next week.
Problem of the week.
Tao. You were too early. Let's try again. Make sure you tune in again next week for another
problem of the week.
And in the meantime, take care of yourselves. Bye.
Bye.